Good evening, everyone. Welcome to tonight's webinar, round 2 of T³IC 2020 virtual sessions. I'm Ruth. I'll be the host for tonight, working in the background. Just a little bit of pointing and clicking here. Down at the bottom of your screen, you might see a chat bubble or a message bubble. If you'd like to click on that, it'll open the chat window at the right if it's not already there. That's the way we'll be communicating this evening. If you look down in the chat window and pull down the screen, it's a drop-down screen, you will eventually see all participants, not all attendees, not all panelists. Keep on going down, you'll see all participants. If you choose that, it will actually send a chat out to all participants. If you choose some of the others, it might not make it all the way to our panelists tonight. And Tom wants to read what you're doing. Thank you, Peter, for trying out all participants and sending it out there. And there's Tom. He's going to be our presenter tonight. Over to you, Tom.
Okay. Hi, Ruth. And thank you for everybody for coming. We're going to be looking at exploring, investigating, and touching quadratics using TI-Nspire app for iPad. So first of all the materials and links to software can be downloaded from this website right here. Take a minute and write that down or take a screenshot or something. It is case sensitive, bit.ly/N-Spire Q quadratics. And I'll show that at the end. It's got tons of information there, things that we might even not have time to. Keep in mind that even though this is going to be done on the iPad, all activities and ideas can be done on any TI-Nspire platform, iPad, handheld, software, whatever you want to use there, okay? It doesn't matter. The iPad app is free for students and teachers only until the end of this month from the App Store, so I strongly suggest you get both of them, the red and the blue. One is numeric and one is CAS. The blue is CAS. And the TI-Nspire software, teacher, and student versions are free for 6 months until August, and I will have links to all of that information at the end. So with that, let me go ahead and pull up my iPad here. Fell asleep while I was talking, and so I'm going to do the screen mirroring. I'm using Reflector 3 to do this. It's very easy to duplicate my iPad on here. You do not have to have this to do this, but it's a good idea to have it if you're going to be using this on a computer. So let me center that there for you. So I'm going to turn on the TI-Nspire app for iPad, and I've got this yellow dot that's going to show wherever my finger touches, so you can see that okay. Ruth, is that yellow dot showing up or orange dot showing up okay?
It is. Thank you.
Okay. So I have several activities that I want to do with you. All of them are available to you as TI-Nspire TNS files. So I'm going to tap on this folder here that's connected to my Dropbox through my iPad. And the first one I want to look at is called Transformations of quadratic functions. I've got lots of things to show you, and I promise you'll see something you've never seen before. Promise. Let me know at the end if I don't hold true to that. So transformations, this one I created this afternoon, but it can be created fairly easily, but you can have it as the way it is. So here is the old y equals a times a quantity x minus h squared plus v. Okay, I used to use h and v, h horizontal shift, v vertical shift. I'm not sure where they got the k from, but I prefer the v. So here we've got y equals x squared, and if I increase a, let's say, you can see now a is 1.5, and notice that I have the parent function in red, dashed red, so that you can always refer back to what the parent function looks like. And one of the things I talked about in the little blurb that goes with this is something called the parabola dance, and I hope you have your students do that. So if I start at the vertex here, on a standard parabola, I go over 1 and up 1, and over 2 and up 4, and over 3 and up 9. And then I do the same thing on the other side with the symmetry. Left 1, up 1, left 2, up 4, left 3, up 9, and that's the parabola dance. I strongly encourage you to do that. It also makes use of this axis of symmetry that goes through the vertex. If I change the a to, let's say, 1/2, now I'm looking at 1/2 x squared, my parabola dance still starts at 0, 0, but instead of going over 1 and up 1, I go over 1 and up 1/2 of what it was, which is 1/2. Instead of over 2 up 4, go up over 2 and up 2. Instead of over 3 up 9, I go up 3, 4 1/2, or 9/2. And then I do the same thing on the other side. So I strongly encourage you to use that parabola dance. There, negative, of course, would be down. So let's go ahead and let students investigate, play, explore, discover the math with their fingers. And let's go ahead and just change V here. So as V increases, you'll notice what happens to the standard parabola. And as V decreases, you know what happens. So this is a vertical shift up and down, whether V is positive or negative. Not that this is a surprise to any of you. Also, you'll notice the equation is telling me that as well. If I want to investigate with H, if I increase H, notice now X, quantity X minus 1 squared is shifted to the right. Shift it 2, shift it 3, 4, and so on. And then if it's a negative, then if it's X minus a negative or X plus a positive, I like to have it X minus a negative to reinforce that, but I would have my students write this as X plus 4. But I want them to see that so that they're getting the right idea here. And then, of course, we can also have A go down to 0, which means it's no longer a quadratic. And then A is negative. And you can see how that dilates the curve. So very simple transformations. Talking about the parabola dance. Kids can play with this, discover things, and that's how I would like to start. So let me stop there for a minute. Ruth, any questions so far? Anybody out there?
Not seen anything so far.
Okay.
We're looking at it.
All right, so we have a small group, so please, I encourage you to send something in the chat, and Ruth will watch that for me. All right, so next thing I'd like to show is, notice when I go to change this, it says discard my changes or keep my changes. Rarely do I want to keep the changes because on an Apple product, it saves as it's going along. This allows it so that we don't have to do that. So I'm going to discard my changes and go back to the folder that has all my files in it. And this one, I've always liked the study card app. I'm not sure if any of you ever heard of the study card app on the 84 and the 83. It was one of my favorites, electronic flashcards. And so I created these way back in 2008 and then redid them yesterday. So that's why it has the 2020. And as many of you know, or some of you may know, I don't like worksheets, but I prefer the word GIFs. So this is a Reardon GIFs for you. So I'm swiping from right to left to go to the next page. It's going to tell me a graph of a parabola is going to be shown, and we want to know the equation of it. And on an iPad, you don't have to worry about Control and Tab. You just tap on the up arrow. So, so here we have a parabola. And instead of graphing it, we're saying we want the equation of it. And so this one, of course, is x squared, drop down 1, so x squared minus 1. And students can immediately check to see if they're right by tapping on this arrow down here. Up pops the answer, y equals x squared minus 1 as an equation. Slide to go to the next page. Hopefully they recognize this. The opposite, y equals opposite of x squared. And I prefer that over negative. Just do. This one, of course, we just talked about a shift horizontally to the left 4 units. A lot of students in Ohio might write this as a quantity x minus 4 squared. And of course, they'd find out right away that's not correct. So x plus 4, the quantity squared. So actually, somebody said something. I didn't get to see what they said, but I'm glad to see something's going on there. And of course, you can just kind of keep playing with this. Unfortunately, they aren't, this one I have both answers here because some students look at it as the opposite of x squared plus 2. Some of them think it's 2 minus x squared. I'd like them to know both, okay? So you can see there are several of them. And as I said at the beginning, if I want to just look at the slides and go down back to the slides, I'm looking at this with the coefficients being 1 or negative 1. I do have another stack where the coefficient could be 2 or negative 2 or a half or negative a half or 1 or negative 1. But I thought I would just show these. So any questions about that?
Tom, we do have a question from Amy.
Sure.
She's wondering about the sliders that you had in your previous file. I don't know if this is an opportunity to talk about that or if that comes at another time.
Sure, we can do that. Let me go ahead and go back to home. I'm going to discard my changes because I opened up all those answers. And I'm going to tap on New and add a new document with graphs. And see how easily done that was, okay? I'm going to go ahead and type in, I'm just going to type in x squared plus some constant. Now you'll notice this is, I love this keyboard, by the way, that's on here. This is the function keyboard. It's kind of like math type or equation editor. If I want to get just the letters, that's this button right here. And what I really like about this are these little buttons there that these buttons right, there's arrows right here that go up, down, left, right. I really like that. So you'll notice some of the letters have a bar over them. That means there's more stuff. Since we can't have a second or a shift or a control or an alt, what you do is I'm going to hold down on, tap on A lightly and hold down. And now I can slide up, say, a C. Okay, pick letters there. X goes with X, Y, Z, T, and U, and F. Okay. So I'm just going to again, write this as x squared plus some constant. I'll just go with C for now. And when I press enter, watch what happens. It says, do you want to create a slider for C? And I'm going to say, sure, I do. And now what I can do is just go ahead and grab this arrow, and it's going to allow me to change the value for C. Now, somebody might say, but it's got that number C, a letter C there. Could I see the number also? And the answer is yes. If I go up here, I can ask, and you know what? I've not done this on the iPad, so I'm not sure about how to do that. How I can go ahead and get the change the, I'm not able to do that here. So I'll show you how we did it on the other one. I'm sorry about that, but that's how quickly the sliders can be added. On the software, I can do that pretty quickly. I kind of goofed on the other.
Hey, Tom.
Yeah.
Can you hear me? This is Curtis.
Yep.
If you make the slider active, if you click on it and it's blue, those 3 bars on the right-hand side should give you the menu. The 3 on the right, that should give you, nope. I thought those were, oh, there it is, the settings right there. Right next to the 3 slider looking ones. There you go. Now you can set that.
I can set what?
The slider settings. You should be able to do those there, right?
I wanted to do attributes so that I could show the letters.
I apologize.
Yeah, that's okay. So, Amy, stay with me. I can do so. Let me go ahead and discard my changes here. Let me bring back the original one that I had. And the original one was transformations. So you'll notice here on this one, I have the sliders like we got created before, but I made it so that the numbers showed up, not just the letters. And so, sorry that I don't know how to do that on the iPad, but it can be done on the software fairly easily. And normally I create on the software and then put it on the iPad. So,
so Tom, somebody, Rose has pointed out you want to be sure and say A times x squared. Not sure if you said that.
Oh, okay.
And showed it to people.
Yeah, that's a good point to make also.
Great thing to notice.
Yeah, so let's go ahead and let me go ahead and add another graph. So if I do A x squared, notice that ax is now a variable. You can have a variable with more than one letter. So what I need to do is put in a times x so that a is considered a parameter and not part of the variable. So excellent point. This is on Nspire, both the numeric and the CAS. It's not an error. It's just we have the advantage now of having more than one letter variable names. And so we have to make sure we do that correctly. So good point. Amy, could you say if that was okay with what I did, or did I mess you up? Yes or no would be good.
Yeah, we'll keep an eye over there.
Okay.
Also, somebody wondered when we were looking at your great study cards, how did you get the questions to be on the right side of your study card?
Okay, again, that would be done on the software. And I'm going to make a note right now that at the end, I'm going to have to stop a few minutes earlier and show on the software how to make the study cards and also how to make the attributes. So thank you for both of those. Thank you. All right, so quadratics, I'm going to go this time, I'm going to go quadratics and how we relate them with zeros, x-intercepts, and factors. I think that's kind of a big deal here. So notice the use of color, the red line, the blue line, the green parabola. So here I have a blue function, y equals x minus 6 right here. I've got a red one, y equals x minus 2. And then the green one is the product of those two. And I have it both shown multiplied out and in factored form. And you'll notice, well, I'm hoping the students will notice what that blue line is, what the red line's doing, as opposed to the parabola. And I'm looking definitely at the x-intercept. So as I change the factors, let's say make this x minus 6 go to x minus 5 and x minus 4, notice all the things that are changing. The factors are changing, the x-intercepts are changing, the product's changing, and so on. And I could do the same thing with the red function. And I can start to talk about the relationship between the factors, the x-intercepts, the roots, the zeros, all that good stuff there, all by playing with the sliders. On the next page, I decided to add in axis of symmetry and the vertex. And so this one's the same idea, except now I'd like to point out where the axis of symmetry is going to be, what the coordinates of the vertex are, and then have students try to think about how do you get that from those two things. One of the things I would want my students to do is realize that the vertex is always halfway between the two x-intercepts, either above or below. You'll notice my parabola dance comes in handy here, over 2 and up 4, or over -2 and up 4 to get to it. And that's where it's right in the middle. It's the average of those two. So I like this. Again, students can play and investigate, explore, and discover the math. Anything there before I go on?
Tom?
Yeah.
Excuse me, this is Ruth. I think if you do a long press on the slider, you might open up the attributes of the slider settings.
Okay, there we go. There's settings. That's settings, okay. I'm going to get attributes. Move, no. Animate, no.
No, but I think slider settings will let you change it to be minimized or.
Yeah, but I wanted to change it so that I can show the variable value. Oh, here it is. Show variable.
Yeah.
Not show variable. Right there. There it is.
There it is.
Right there.
So, repeating, that was a long press on the iPad. That's how we got that pop-up menu.
Right. So a long press and hold down, and then under settings, one of them is show variable or not show variable. You show the variable, you see the letter, or you don't see that. One's the value, one's not the value. So thank you, Ruth, for that.
You're welcome.
I'm glad we figured that out.
I was glad I was able to find it.
Good. All right. Oh, you got it. Good. Good. Yes, Curtis.
There's a question about how do you get the value to show up in the actual equation. That's an attribute of the equation, not the slider. So you have to do the same long press on the equation to get the menu there.
Okay, so I'm going to go ahead and do that to show everybody so that we know that works. So again, I'm just going to go with x squared plus some constant, maybe b this time, okay? And I'm going to create a slider, okay. And now when I go and I hold down the equation, not there.
Not on the equation, on the graph itself.
Okay.
Do a long click there, you should get that menu.
Okay.
Now you should get that.
Now what?
It's selected. You have to do the long select. I think that should give you that. Is that not giving you the attributes menu?
No, it's not.
Hmm.
No, it's starting to flash after I hold it for a while.
Hmm. Okay.
All right, so I'll come back to the software and show it. I'll come back to the software and show it.
I'll keep working. It's an attribute. We'll find it.
Okay. All right, so another thing I'd like to show is the quadratic formula. And that's not where I wanted to go. Quadratic formula, I have that embedded. I like to embed it. So for this one here, you can define functions on either version of TI-Nspire. And so I'm going to go ahead and go on to a calculator page, and I'm going to define a function of 3 variables. And so I'm going to tap on the tools, that wrench there, and under actions, I'm going to define a function. Define. And I'm going to call, I need 2 parts because there's 2 parts to the quadratic formula. So I'm going to use the alphabet keyboard, and I'm going to call it QUAD1, meaning the first quadratic. And it's going to be in terms of A, comma, B, comma, and C. And I know somebody said, well, why don't teach my students functions of 3 variables? But I think it'd be okay to do this. I have done it. I've worked it with even with freshmen, and it's a great way to get them thinking about functions. So this is equal to, and then I'm going to go back and get a nice fraction template. The opposite, not the minus sign, but the opposite of, notice I'm sliding to B, plus the square root, again sliding to B, squared, minus 4. I'm going to put the times sign, even though I don't have to here, A. I do have to put the times sign in before I put in for the C. And then down in the denominator, 2 times A. So there's my half of my quadratic formula. And now I'm going to type in the second half. But since I'm lazy, I'm going to use these up arrows here to highlight and paste it down. And now I can edit very easily. Look how nice and easily I can get through here and backspace and delete, make that a minus sign. And then go over here and make this quad 1 and change that to a 2. So now I have the quadratic formula in my calculator or in my iPad app, and I can use it as long as I'm in this document. So for example, if I type in quad, Q-U-A-D, you'll notice it's all italicized. Watch what happens when I press the number 1. It becomes bold, meaning it's been defined. And let's say I wanted to solve x squared minus x minus 6 equals 0. So that would mean A is 1, comma, B is negative 1, comma, and C is negative 6. And one of them is, I think, 3 and negative 2, or negative 3 and positive 2, 3. And if I want to do the same thing but with quad 2, I can just go ahead and change that 1 to a 2. And it'll give me the other solution, negative 2. It'll give me any, if I set it for complex, it'll give me complex fruits. If I get irrational ones on this one, it'll give me a decimal approximation. If I do this on a CAS machine, it'll give me exact radicals for the answers. So again, I just defined it, and it's there throughout that whole document. questions on that? Any questions there?
Not seeing any questions there, Tom. Thanks.
So Karen just popped up a question just as you were answering that, Ruth, and said, is there a way to embed it? And the answer is yes. That's my next part. So you actually can create a function and put it into your library. So here I have the quadratic equation formula. And again, you'll have access to this. And it's defined as two functions, but you put it in your public library. And then when you want to use it, you have access to it. And so right here, again, you just run it and put it in your library, and you can get the solutions. And again, that will be available to you in all the documents. So thank you, Karen, for that question. All right. So one of the things I also love about Nspire, and I'm hoping that's what most of you guys use is Nspire, is to be able to use this as a tutorial. So I have a tutorial that goes through step by step. I think this is the one. Yeah, step by step, 2 examples. And I like the students to use this basically as like a teacher sitting next to them. And so I'll say this is used to solve, and quadratic formula is used to solve any quadratic equation, but especially when it can't be factored. And so here's the quadratic formula, and I make sure my students realize the quadratic formula has 2 parts. That if part is just as important as the then part, because if you don't have a times x squared plus b times x plus c set equal to 0, then you can't use the quadratic formula. It must be in that standard form. And then if it is, you can find x in those 2 different parts. So I also like to make sure that they think that is the opposite of b. There are 2 examples. What I'd like you to do is have students try to do these, and as they do that, as they get stuck, flip to the next slide. So, for example, it says solve this, do it on your paper, proceed to the next page to check your work. So I know some students won't do that, but the ones who will, I think this will benefit them a great deal. So we'll go ahead and do this, and now I'm just going to flip through the slides here. And the first thing I have to do is get it into standard form, which is set equal to 0. And so that's what this would look like right here. And then they can identify the values for A, B, and C, 2, 3, and positive 6. This is just, again, just kind of helping them with that procedure. Some procedures still have to be taught. I like to think of generalize and more other things, solving problems, which we will get into in a little bit. So I have them write the second half of the quadratic formula. What does x equal? And then this is where they have to be really careful. They have to substitute and make sure the values go into the right spots. By the way, you'll notice I hit a wrong number and I just did an undo over here. Undo is over this case right here. There's double arrows. After they substitute, go ahead and simplify using the order of operations, and you can see we're getting imaginary solutions here. And so that would be your solution set. But I also like the idea of having students show how to check it. And this is, again, very, very important to me that they do this. So what I can do is take the left-hand side of the equation and write 2x squared such that x equals one of the solutions and see what answer we get. And then do the other side of the equation such that x equals the same value. And notice we're getting the same numbers on each side. So that means there's an equality there. I can also show both sides on using the minus part of that solution and get the same thing on both sides. There is another example. I'm not going to go ahead and do it. It's very similar. You get the idea. But I love using TI-Nspire as a step-by-step. One of the things I used a lot was our students had their own Nspires, and if they do or had their own iPad apps, if I couldn't get to a certain problem, I would give them that document and say, go ahead and do these 2 problems before you start your assignment. Just like me teaching, I'm just not there to talk. So again, step by steps, I'll do a couple more a little bit later. Ruth, any questions there?
I'm not seeing any yet. Thank you.
Okay. All right, so let's go ahead and apply this. This problem is a standard Algebra 2 problem, I think. I call this the aluminum gutter problem. It's a mathematical modeling and applied application problem. And so here is the problem. It says, here's a rectangular aluminum gutter created from a flat sheet of aluminum that's 12 inches wide. An equal amount of aluminum is bent up on each side as shown below, and the area of the cross section must be 15 square inches. So I'm going to go ahead and push this to the side for a minute and pull this up. And so this is the problem. Hope I don't lose that iPad. So here's what the problem looks like. I just want to go through the hand part, the hand by hand part here, okay? And so the first thing I'd ask my students to do, or I hope they would do, is make a sketch of this. If they made a sketch this nice, I would be completely surprised, okay? But just a decent sketch. And then I would like them to make sure they can represent X with what it should be. In this case, it's going to be the distance it's bent up on each side. So X is going to be this vertical distance here. All right, what is the length of the bottom of the gutter in terms of X? So that double green line there, or double green question marks, how long will that be? And again, this is probably the key part to the problem, that and the next part. And of course, it's 12 minus those two X's that we cut off, that we bent up. We want to model the area in terms of X, that is come up with in terms of A of X. And so if we draw the rectangle, it's going to be base times height, or in this case, X times the quantity 12 minus 2X. Those are the two things the students have most trouble with. Technology is not helping a whole lot with that. Then we want the area to be equal to 15 square inches, so we set those equal, and then we go ahead and solve for X. And we get this quadratic equation in standard form that unfortunately cannot be factored, okay? And since I've already shown you this, I think I'll just go ahead and show you what you get here. So we already had this typed into the calculator, into the handheld or into the iPad. We go ahead and put the numbers in and get the answers. And it turns out when I do one, I get this answer for X, 1.77 something. When I do the other one, I get 4.22 or something. And so I stored this into the variable called height. And remember I said before, you can have variable names with more than one letter, which is an advantage. I stored this in height 2, and then I did 12 minus twice the height to get the width, and I did it again and got a different width, and I called those width 1 or width and width 2. And then what I did is I multiplied those two numbers, and I got 15 to show that they checked. And again, that's the power of using variable names, storing intermediate answers. Question just came up, can we get it in its radical form? If you have the TI-Nspire CAS version, the blue version, which is free right now, absolutely these would come out in radical form, in simplest form. So my suggestion is get both of them, the red and the blue. They're free until the end of the month. Glad I could catch that, Karen. All right, so here are the dimensions that to 3 decimal places are final answers. 2 different solutions, both are possible, which really surprised me that we had a problem that had 2 answers and they both would work. Any other questions on that applied problem? I'm going to say no. All right, so it looks like I got to bring my iPad fell asleep again.
I'm going to send out a chat question just to see how many teachers are trying to find out how many teachers are teaching with iPads.
Okay. All right, so oh, by the way, the teacher version of this, let me just show the teacher version of this real quickly. I have two versions. One is the student version, and one is the teacher version, and that's the student. Go back and get the teacher version. And the teacher version has, well, you know what? I have it on PDF. We'll just do it on the PDF. That would be better. All right, another step-by-step solving quadratic inequalities. So let me
Thank you for your
on
responses
that.
out there about teaching
sorry.
with iPads. So it looks like fairly well represented with the teachers that we have on tonight of teachers.
Okay, so they do have iPads. Great. Okay. So teacher software, I just saw how do you get TI-Nspire software. There's a 6-month free software also on the website I'll show you at the end. And I am going to show the software at the end too because I wanted to show you a couple of things that came up while we were talking here. So excellent questions. We will talk about the software. You'll get it for free. All right, so this is another what I call step-by-steps. I'm curious at the end if people like these or if I'm the only person in America that likes these, so you could tell me that at the end. But this is an example. We're going to solve and graph x. When is x squared greater than or equal to negative 3x plus 10? A colleague of mine asked me today, do you really use these very often? And in calculus, you have to know when an expression is positive or negative. So you know whether a function is increasing, decreasing, concave up, concave down. So yes, we use this a lot there. So here, again, I have it step by step. I would prefer the students kind of went along with me. So the first thing I'm going to do is get the right side to be equal to 0 legally. And I say legally because I have some kids just erase it and put in a 0, and that's not really helping us any. So we get the equation, set it equal to 0 to find the zeros of the equation. We factor it, set each factor to 0, and solve. Of course, we get -5 or x equals +2. And so these two numbers separate the number line into interval. And we want to find out which ones are positive. That's our goal, okay? So what I do is I make a number line like I have here, and I put in the 2 zeros, separates into 1, 2, 3 intervals. And we're going to pick a number in each one of those intervals to see whether it's positive or negative. That expression is positive or negative there. And so we're just, again, going through step by step, just like I'm sure you do in your classroom. It's just there for your students to be able to use. And so I'm going to go ahead and first pick a number greater than 2, and it could be any number. Most people might say 3. I'm going to go with 10 because to me, 10 is pretty easy to work with. And when I substitute, I get 15 times 8. I don't even care that it's 120. I just know that it's positive. So right up here, I'm going to put POS for positive. Pick a number between -5 and 2, any number. If I can pick 0, love to use 0. So I'm going to pick 0. 5 times -2, -10, clearly negative, so negative goes up here. And then finally, a number smaller than -5, I pick -10. I'm getting negative times negative, which is positive, so positive. I still need to graph the solution set. So we want to know where it's positive, so that's these two intervals. And we also want to include the endpoints because it says greater than or equal to. So we're going to have closed circles and the arrows going in opposite directions. That's our graphical solution. And of course, our numeric or algebraic solution is in set builder notation. The set of all x, such that x is less than or equal to -5 or x is greater than or equal to 2. We need them both. So I'm just curious, does anybody else like those, like the step-by-steps besides me, or is this it? Am I the only one? I'm okay if you say I'm the only one. But one, I love it. Okay. All right. Good to hear. Good to hear. Thank you for your replies. All right. We're on time. So I'm sure one other word. I'm going to go. Curtis Brown is on with us tonight. Curtis is a colleague of mine, and we work together a lot. He works for Texas Instruments, former math teacher in the Dallas area, and originally from Oregon. And he gave me this idea, and I just kind of ran with it. And it's mainly his idea. Okay, so if you love it, it's his. If you don't like, if you love it, it's mine. If you don't love it, it's his. How's that go? There we go. Okay. So fun with quadratics in standard form, looking for patterns. Thank you, Curtis. Thank you, Curtis. All right. So here's the deal. And he brought this up, and I really like it because not that this is kind of something that's ever going to be tested on ACT, but it has patterns, and I'm always looking for my students to look for patterns, and then generalizing those patterns. So there's some couple things here that came up that were completely unexpected. And this is my 40-some year being a mathematics educator, never saw this before, okay? And working with technology makes it easier to play with. So I have this function, it's just a quadratic, okay? And what I'd like to do is graph the same quadratic, but change the coefficient of x squared to be its opposite. So it's not the negative of the entire function, just negative of the x squared. So I have that in F2. And so I'm going to put a check mark there so it'll graph in red. And you'll notice I've got the blue is going up, the red is going down, but they intersect at a particular point. And it turns out that point is the y-intercept. Okay. Now I was wondering, and that kind of threw me. I didn't expect that. Okay. I didn't know what I expected, but I didn't expect that. It looks like they're both tangent to the same line. So I was wondering if I could get a tangent line that would go through that point and see what its equation would be. So I know the y-intercept. The y-intercept is already here at -4. I got that, but I don't know what the m is. So I created a slider like I did before, and I'm going to now bring in f3 that I typed in as f of 3 of x is equal to some number m times x minus 4. Again, the time sign's there. And, oops, forgot to turn it on. Sorry about that. And click turn it on. And so this is not the line that's tangent. So I'm going to go ahead and play with the slopes. And I'm going to stop when the tangent line looks like it's the slope is the right tangent line. And I'm thinking it's right there about at -3x minus 4. And hopefully you guys will agree with that. But I'd like you to look at my answer and look at my equations. Is that a coincidence? Okay. So I tried another example. I did a different one. Now the 2 is the coefficient of x squared. And I did the same thing. I went ahead and did F2, and it was the opposite of the 2x squared. And again, it happened to intersect at the y-intercept. And again, I'm going to throw in that slope tangent line. Turn that on in black, okay? And let's see, is that, ooh, is that it? No, that's not it. Smaller, smaller, smaller. Ooh, looks like it. But Curtis also suggested, he said, you know what else? You can find the tangent line if you just go to the tools and go to geometry. No, I'm sorry. Go to analyze graph. No, go at geometry. Sorry, I was right. Geometry. And look at points and lines, tangent line. And I want to know the tangent line to this blue curve through this green point, and look what it is. It's y equals 2x plus 3, but look at the equations, and look at there. So I did another one with -1/2, but not surprisingly, it wasn't, the results were still the same. So I'll turn that one on, and I'll turn that one on, and I think you can kind of guess what the slope of the tangent line is going to be. And so we decided there's got to be some kind of pattern. And how would I test this? Not how would I prove it, but how would I test it? So sliders was our answer, or Curtis's answer, I should say. So I've got this function here, and notice how I created it. When I go into here, I typed it in as ax squared plus bx plus c, which was the standard, the general form, not numbers anymore, the general form. And so what is my f2 going to be? Hopefully you can anticipate what f2 is going to be. Yeah, it's going to be the opposite of a, x squared plus bx plus c. So let me do that. There it is. I'll go ahead and turn that one on. And let's see what we've got there. And notice we've got this, and we can go ahead and play around with different A's, different B's, and so on. But notice that the point of intersection is this y-intercept. But how about now? Here's the part that's cool. How about if I bring in that tangent line? So again, I'll bring in the tangent line. And what did I use for it? What did I use for it? If I had ax squared plus bx plus c, what's the equation of my tangent line? Wait for it. bx plus c, which is going to mess up, I know, a lot of students because they think b is always the y-intercept. This is just going to crush them and ruin their days. I'm sorry. But it's bx plus c. Let's go ahead and look at that. And notice that it is the tangent line. And here's the dynamic algebra. Here's the part I love. Watch how when I change b, look at what's going on there. And b is 0. Notice we've got the vertex right there on the y-axis, and so on. I mean, this is just beautiful. This is beautiful mathematics here. A doesn't seem to do a whole lot, and C just shifts up or down. But B is really the thing we're investigating here. Okay, and look at how that just goes and goes and goes. Oh, by the way, when A goes to 0, let's look what happens when A goes to 0. Everything becomes the tangent line. Everything. Anybody think that's cool yet? I don't know if anybody react yet. Okay, we got a wow. I'll take a wow. Wow is even better than cool. But just like the Ginsu knife commercial on TV late at night, wait, there's more. Okay, wait, there's more. So we got this here, and I brought in the vertex. See this pink vertex point here? Okay, and I was wondering, I'm again bring in, I think I've got F2 coming along here. Let me turn in F2, okay, there. And again, I'm going to go ahead and play with A and play with B, and you'll notice that we've got that going on. But what I'd like you to do is, here's what I want you to do. I'm going to make B an extreme value, -5. I want you to watch this pink point here. Watch this pink point as I change B. And I want you to see if you can see what it's tracing out. Anybody see what that's tracing out? Pink point, what kind of curve? And so to make this even easier to understand, what I'm going to do is do something called a geometry trace. I'm going to go to trace and do a geometry trace. And I'm going to trace on this pink point. And what that means is it's going to leave it behind. Somebody said another parabola. You were absolutely right. So watch what happens as I change B. It's leaving that where the vertex was. And that's as far as I can go, okay? Which I thought was kind of cool. But what's its equation? What's the equation of that pink one? Well, you can see that it has a y-intercept of 1, so it's got that +1. It's upside down, so it's got probably, it looks like a -1 x squared, okay? And so it's -x squared plus 1. So let's go ahead and turn off the geometry trace. And let's bring in room to type in, what did I say, the opposite of x squared plus 1. Bingo. Oh, it was even pink. Oh, how nice is that? Okay. And again, I could kind of generalize that if I wanted to, or if I had time or whatever, but anybody think that's kind of cool?
A lot of people think it's cool.
Okay. So
Tom,
Curtis?
blow their minds and change A and do that same thing.
Okay. So I'm going to have to go and turn off the geometry trace. Let me clear that geometry trace. Erase it. And so what do you want me to do?
Change
The
A
same
to
thing?
something other than 1.
Oh, okay. Okay. And geometry trace. Oh, did I lose the pink point? It's like I lost the pink point. The trace on. So let me get that quickly. Is that the one, Curtis, right there?
That'll work. That'll work.
Okay. Trace, geometry. All right, so now let's try this point right here. Ooh. Did I
What
do
happened?
something? I think
Oh.
I didn't hit the vertex, I don't think.
No, you hit the vertex. You hit the vertex, but you use the find maximum, and you have to put a point on there. I'll spoil it though. I'll spoil it. We don't have lots of time. So what ends up happening is really cool. Is that it traces out opposite of ax squared plus c, and so the vertex will follow opposite of ax squared plus c. And like somebody said a minute ago, stop the linear term. Amy Anderson called that out. So that's exactly it. You're pulling that linear term out. It's really cool.
Okay, so while we're here, I decided to extend this. I thought, what if we went to a cubic? And I don't have a whole lot to say, and this is on quadratics, and I'm not supposed to do cubics, but bear with me here. So look what happens here. They are tangent to each other. And it turns out that when you like we had a tangent line, we have like a tangent parabola that somehow comes into play here. So I'm kind of running out of time, but I just thought I'd throw that out there. You can get the file, you can play with it, do whatever you want with it there. So there. All right, so let me switch over to computer mode.
Oh, before you leave your iPad?
Yes.
Okay. Just backing up a little bit. Could you get a graphs page, pretty please?
Mm-hmm.
And just put x squared plus c, something that we were looking at a while back. Feels a little bit anticlimactic now after I was just blown away with your previous problems.
You want a slider for that?
Sure.
Okay.
And this is actually less about the slider than attributes of the graph.
I didn't like that.
You told it no. You do want a slider. Do plus D or something, or F or G. Yeah.
Okay, there we go. All right. Go ahead,
Okay.
Ruth.
So back to where we were before, and somebody said, how do you get it to display, change the appearance of that equation, the expression for F6 there. So like on software, you're going to probably show us there. And on the handheld, you might do a control menu to get that context menu. So just on the iPad, a couple things are different. We already saw that the long press was different on the slider. So on this, if you just tap on the graph, and then see what your attributes will do. And your attributes are the three bubble sliders that are kind of up there by tools.
Okay, so I was trying to get those before, but I must have held down on it. When I was holding down, it wasn't working. So tapping worked.
Right.
So
So
here's
that's
the
like
way.
a right click on a mouse or the control menu, a control menu for context menu.
So notice, as Ruth said, if it's A, it's showing the letter. If I show up what A equals, I get the number. So there's where it is. So thank you, Ruth, for figuring that out.
Thank you for showing us.
Oh, I didn't show you. I didn't.
You did.
I mean, yes. Okay. All right. So
Thanks for saving us all there, Ruth.
Yeah.
So let me show you where you get all the what I think is the good stuff. Okay. So this is the website. This is the link, or the website for you, bit.ly/Inspire Quadratics. N and Q are capitalized. Okay. And when you go there, it's going to look a little bit overwhelming, but please do not be overwhelmed by it. So these are, anything bold is a link. So if you click on the first link, all of these files are in there as TNS files. All in there is one zip folder. So when you click there, it'll take you to this here. And what you need to do is to download this and unzip it. So click on there, download it, unzip it, you've got it. Don't open it. You can't open it. You have to save it and then unzip it. But all of them are there. They're all yours. Okay. The aluminum gutter problem, if you would want to get the teacher notes and solutions, there's a PDF for that. Also right here are the student PDF and the teacher PDF. Student PDF is almost not necessary if you have Inspired because it's all written there, but this has the solutions for you. Math Inspired has over 1,000 pre-made activities with student sheets, teacher notes, the TNS files. Unfortunately, I'm not going to be able to go there and show you any. We're really running out of time, but here's what you've got all these separated by course. If you go to Algebra 2, there's a whole thing on quadratics, repeating the square, discriminant testing. I was hoping to show this modeling the basketball shot, but we had great questions, so we didn't get it. I think that was better that we answered questions. More information about the Red iPad app. This is the Red iPad app, explains more about it here. Here's the blue iPad. Oh, where's the blue iPad app? I guess it got disappeared. But there's the one on the blue iPad app. Remember, the red is numeric, blue is the cast. They're both free. Get them. They're normally $30. No, they're not $30. $29.99. They're not $30. More information until August 15th. The software, here's the teacher software, is free. If you go there, you can get either the 84 emulator software, you can get the SmartView from TI-30 and 34, and here's the premium software, and you get both the blue and the red, okay, both the numeric and the cast, both free in one. Great, great deal. Okay, you do all kinds of stuff with that. The student software, please encourage your students to get student software. They can also get the 84 emulator and this for these calculators. And for the red and the blue. These are separate to the students because they don't have the same power the teacher has, okay? Also, you should be aware if you have any teachers that use Chromebooks. Finally, I shouldn't say finally, that's terrible to say, but finally there is an 84 solution that they worked on and have an app, and this will work until August 15th to just complete the form, and within a day or two, somebody will send you out the app, which I have, and I love it. I've been using it for a while now. In fact, I'm doing another webinar a week from tonight on the Chromebook and disease mathematics. What else have we got? Math Inspired, Chromebook, 1-800-TI-CARES, TI's website, and I've done 2 previous webinars on iPads. This one was on geometry. You're welcome to get that stuff. And just a generic iPad, you're welcome to get that stuff. And with less than a minute left, thank you, Ruth, for
You're
for
so
helping.
welcome. Thank you. Do you have your teacher software launched? Inspire software launched?
Yes, right here.
Okay. If you want to do a quick answer the question of how did you get the question on the right side. So.
Okay. So, I haven't done this for a while, so let me go ahead and insert a page.
Right.
And
insert problem, maybe.
So
insert question.
question.
That's what I meant. There you go.
And then I want, let's go with ABC. No, let's go with custom choice here. So there's the problem right there. Do I even want to do it that way? Let me do this one more time. Let me go with insert question. Oh.
Let's do a graph like y equals or f of x equals. A question that has a graph in it down there, equations and expressions.
All right, so there's that. I guess I do have to split the page. And if I want these to be over here, I could have put it over here. Let me do it one more time. And somebody said, we just made all those. They were I had all those in templates, so that's why that's that way. So here I'm going to insert here. There it is. And now I can go ahead and put a graphs on this side.
Okay, so to insert a question like that we were using in the study cards, you do need to use the teacher software to insert a question there. And you can do a split layout there, or if you have a graph, you can have a graph preview, which will show the question on one side. And
one of the ways you could do it, I would suggest, is get one of mine and just like erase what's there and put in your own. And once you have the template for one, you just keep copying and pasting it and duplicating it.
Excellent.
So went over a little bit. Another question?
Another question. As we switch over to our final slides, talk to us about how you got your iPad to show up on your computer.
Okay, so there's a program called Reflector. And in fact, if you go to where is it? You know what I'll do? I'm going to put on the website that I created the link to Reflector. And I'll just tell you real quickly, if you go and get Reflector 3, it's free for, I think, 2 weeks or 5 days or something, and see if you like it. It's about $15, and you put it on your computer, and then you can actually have your iPad connect to that, sync to that, and it tells you how to do that. Not only that, I was able to get my Chromebook to go to my computer screen. So if I want to display something from my Chromebook, I can use Reflector 3 also. But I will put that link to Reflector 3 on the website that I created.
Okay, thank you. And Melanie has sent out some more information about Reflector in your chat window, so please check the chat window. The session is recorded, and the recording will include the chats. We had briefly had up there information about a link for certificate of attendance. I'll put that back up. I wanted to evidently click on everything but the one that I wanted. Here's where Tom was talking about software licenses for the teacher software and the student software. Apps for iPad and Chromebook. This information is included in the chat window and also at education.ti.com. Right? And let's see what else we need. There was your certificate of attendance. You'll probably get an email in the next couple of days that includes this link again. Thank you for attending, and we'll have that link again. At the end of tonight's session, you'll get a survey about the webinar. So if you have time, please take that opportunity to let us know. 1-800-TI-CARES, technical questions. You'll get a link to this document with slides for tonight, and you'll also get some information with Todd, with the link from Tom. I'll put that out in the chat one more time in case you didn't have a chance to see it. Tom's link right there. Write it down, save it. You know you love it. Bookmark it already. Thank you so much for being here tonight. Thank you, Curtis, for joining us. Thank you, everybody, for your great comments and for sharing. Tom, thank you, thank you. Can't wait to hear what's going on next week.
Okay. Have a good night, everybody.